Have you ever wondered how big companies make complex decisions? The answer is operations research. Picture this, a maze of decisions, all interconnected, all impacting one another. It's like a game of chess, but instead of one opponent, you're playing against 1,000 variables. That's where operations research steps in. It's a field that helps us navigate through this maze, making informed, effective decisions. In this video, we're going to delve into the heart of operations research, exploring the fascinating concepts of dynamic programming, linear programming, and nonlinear programming. These aren't just academic terms, they're powerful tools used by businesses around the world. They help us optimize resources, minimize costs, and maximize profits. They can even be applied in our daily life decisions. Can you imagine a world without these decision-making tools? Well, you won't have to. Ready to dive into the world of operations research? Buckle up. So, what exactly is dynamic programming, and how is it different from linear programming? Let's delve into it. Dynamic programming is a mathematical technique used to solve complex problems by breaking them down into simpler subproblems. Imagine you're planning a trip across multiple cities. Instead of calculating the total distance in one go, you'd break it down city by city. That's dynamic programming in a nutshell. On the other hand, linear programming is a method used for achieving the best outcome in a mathematical model whose requirements are represented by linear relationships. Picture a farmer trying to maximize his crop yield using a fixed amount of fertilizer and seed. He'll use linear programming to find the optimal mix. While both methods aim at optimal solutions, dynamic programming is more versatile, solving a wider range of problems, while linear programming is often simpler and more efficient for problems with a linear structure. Are you following so far? Here's a question for you. Can you name an industry that heavily relies on dynamic programming? Now that we've talked about dynamic and linear programming, let's discuss nonlinear programming. This is a method used to solve optimization problems where the objective function or the constraints are not linear, meaning they don't follow a straight line pattern. It's like trying to find the shortest path in a hilly terrain where the slope is constantly changing, rather than a flat field. Think about a logistics company trying to minimize fuel costs. The relationship between speed, fuel efficiency, and cost is not linear. It's more like a curve. Going too slow increases travel time and labor costs, while going too fast burns more fuel. So, the company uses nonlinear programming to find the optimal speed that minimizes the total cost. Here's another question. Can you think of a real-life example where nonlinear programming might be used? Keep that in mind, and we'll dive deeper in our next video. We've covered a lot today. Now let's see if you've been paying attention. We started off by stepping into the world of operations research, understanding the vital role it plays in decision-making processes. We then moved on to explore the key differences between dynamic and linear programming, and how they each have unique applications in various industries. We dug deeper into dynamic programming, understanding its recursive nature and how it breaks down complex problems into simpler sub-problems. On the other hand, we also looked at linear programming, highlighting its ability to optimize resources and activities given a set of constraints. Next, we ventured into the realm of nonlinear programming, which, as the name suggests, deals with equations that are not linear. Despite its complexity, it has far-reaching applications in fields like economics, engineering, and even in the creation of artificial intelligence. Now let's test your understanding. Here are your final 3 questions. Can you give an example of a real-life situation where dynamic programming can be used? How does linear programming differ from dynamic programming in terms of problem-solving approach? Can you name an industry where nonlinear programming might be particularly useful? Take a moment to think about it. Alright, here are the answers. Dynamic programming can be used in inventory management to decide when and how much to order to minimize costs. Linear programming uses a straightforward approach to solve problems, while dynamic programming breaks down problems into smaller, manageable subproblems. Nonlinear programming is particularly useful in the energy sector for optimizing power generation and distribution. Do you have any thoughts or questions about what we discussed today? Feel free to drop them in the comment section below. We'd love to hear from you. Don't forget to like, share, and subscribe to our channel for more such informative content. Also, check out our website beawarechannel.com for premium content and other exciting stuff. Can't wait to see you in our next video.